Welcome to part 2 of building your own Pocket platform with Lightsail and Docker. And in this part, we're going to actually roll up our sleeves and start deploying our virtual machine within Lightsail. I'm going to come in here into the Lightsail console, and now it's time to click this Create Instance button. And here I'm going to choose Linux. Under Select a Blueprint, I want to select OS only, and I'm going to select Ubuntu 18.04. And then down here, for this demo, I can really select any of these instance types. Any of these instance types will suffice. So if you're just playing around with it, feel free to choose the cheapest one. I'm going to choose the $20 instance because I'm a high roller. And I'm just going to identify my instance here. So this is the virtual private server that we're going to use to host our raccoon.news site. So raccoon news. And I'm just going to leave key only tags and key value tags empty, and I'll just click create instance. So while this instance is spinning up, let me describe what we're going to do next. We're going to attach the the static IP address that we allocated in part 1 of the video series. And by doing that, we're basically replacing the dynamically generated public IP address. You can see that IP address is already available here. And that's the reason why we allocated that static IP address, because if we were to go and update all of our DNS records to point to this newly dynamically allocated IP address, it might take a while for that to propagate, during which time our users are not going to resolve raccoon.news as a domain to the correct IP address. And by using the static IP address, we know that every part of the DNS system is going to be correctly caching the static IP address, and then now we can just reassign the static IP address, which takes a lot less time. So I'm just going to click Manage here, and I'm just going to scroll down and say Networking, and then I can click Attach Static IP Address, and then I'm just going to choose the static IP address that we created. And click OK. And there you go. This is now the static IP address. So if I ping for the static IP address and this machine is listening, then I'll be pinging this machine. The next step that we want to do is open a few custom ports. So you can see here that by default, Lightsail has created 2 firewall exceptions, one for port 22 for SSH and one for port 80 for HTTP. That's very handy, but it's not quite enough because, as we mentioned in the functional requirements, we need to support SSL. And SSL happens on port 443. So I can just click here, add another, and they even have HTTPS down here for me to select, so definitely want that. And then one more port. This is TCP. I'll leave it at custom. There's no name for this. And the value of this is also arbitrary, but I'm just going to choose 2222, something that I can remember easily. And I'll come back in a moment to explain why we needed to add this port. Just remember that if you chose a value other than 2222, just write it down somewhere. We will need to refer back to it later. The next step is to connect to this instance. And to do that, I'm going to click the Connect tab here. And I can connect to the instance using SSH here. But since we're using WSL terminal, we need the SSH key pair. And it says down here at the bottom of the page, you can download your default private key from the account page. I'm just going to click that. Click download, and then I'm just going to grab this file here and move it somewhere into temp for now. I'm just going to rename this file something a little shorter, lightsail_ssh_key. And the reason I'm doing this and putting it in under ctemp is because the file path for your Windows subsystem it depends on the distribution you're using, so it's a little hard to remember. But what we can do is we can come in here and we can do ll and find the file pretty easily like this, right? So we can copy this file here that we moved under temp, and I'm just going to move it locally right here. So now I have my sshkey.pem file right here in my home directory. Now the next step is that we need to restrict permissions for this SSH key. If you don't do this and you try to use it, SSH will correctly warn you that the permissions are too open and anybody can access this file, and that's not what you want. So we're just going to write change permissions here to 400, and then now we've changed the permissions. So the next step is to specify this SSH key pair file as an argument when we run SSH. And the way you do this is it's just SSH-I followed by the file, and since the file is right here, I'm just going to type the file name, press tab, and I get autocomplete. And the name of the account that's been created for you by default in your Lightsail instance is Ubuntu. So you write Ubuntu @ and then now we need the static IP address. But remember, we actually pointed the domain settings for raccoon.news, that whole domain, we pointed that to the static IP address. So even though I don't remember the static IP address off the top of my head, I can just type raccoon.news here and this should work. Let's try it out. Okay, so it's just saying that the fingerprint should be recorded. Yes. And there you go, I am logged in. At this point, we have a clean instance of Ubuntu. There's nothing installed, nothing pre-configured. But before we start to turn it into a platform, let's take an overview of what we're trying to achieve. Now, in this box to the right over here, this is our server. And imagine that for raccoon.news, I'm going to start deploying several services. I want to deploy a blog, I want to deploy a site where users can go and buy raccoon accessories, and I also want to have a support site where raccoon owners who are having trouble with their raccoons can request support. Now, if this is the structure of my stack in the back, I'm going to need a way to route these requests to the correct place. And that's what I have here in this box, this nginx proxy. And so you can imagine that users, through our DNS settings that we've configured earlier, are resolving to this correct IP address. They're hitting port 80, and then they're hitting the nginx proxy, and the nginx proxy can route these requests to these different containers based on the headers. That is, when you go into the browser and you type in something like blog.raccoon.news, that entire URL is included as a header in the HTTP request. And when that HTTP request arrives on the server, nginx proxy takes a look at it and goes, oh yeah, blog.raccoon.news, I know where to route that over to the blog container or the blog process. But in order to support SSL, that's on a different port. SSL port happens on port 443. And what we really want to happen here is if nginx detects an incoming HTTP request and SSL has been enabled, then we want to bump that request over to port 443. And that's very easy to do, as we'll see shortly. But when that request comes through, now we need an SSL certificate. Otherwise, the browser is going to warn you that this is not a site that you should trust. And that means that we need to issue these SSL certificates, preferably in a way that is as hands-off and as automatic as possible. And that's where we're using this lets-encrypt-companion process for this box right here. This thing's job is to basically watch for new processes, new services that are started up on the back end over here. And whenever it detects a new one, it's going to say, hey man, I assume that you want an SSL certificate for this. So it's going to use certbot, which is the Let's Encrypt client, and it's going to call out into the Let's Encrypt service to issue a certificate with the subdomain that matches the newly deployed service. And we want these two containers to kind of run as automatically as possible, preferably zero configuration after we've deployed them. All right, now we're ready to run commands to start to configure our instance to turn it into a platform. And in order to do this, we're going to start running a bunch of commands, but I don't want to just run these commands and just see some results at the end. Let me explain what we're actually trying to do here. The first thing we're going to do is install Docker. Now what Docker lets us do is basically run commands so that we can run various components in their own containers. And a lot of you have already probably used Docker, but it's beyond the scope of this video to fully explain it. In short, you can think of Docker as a neat way to package up applications and make sure that they run in a reliable way. And for us, it's also going to save us a lot of time and complexity in terms of configuring the software, downloading it, configuring it, installing it, running it, making sure it stays running. All this stuff is eased by having Docker at our fingertips. The second thing that we're going to be using once we have Docker installed is something called nginx. nginx is a very cool piece of software, very versatile. People use it for all sorts of different things. They use it as a web server, they use it as a proxy, they use it as a reverse proxy. In this case, we're going to be using nginx as a reverse proxy. And what you can think of reverse proxy is like a telephone switch operator. You know, back in the old days when we had people manually switching calls from one another, they would get a call coming into the call center and then they can switch that line to the number that it's supposed to be connected to. And that's kind of what we're using nginx here for. We're basically going to get requests at some subdomain, and that subdomain request is going to come into our instance, and nginx is going to get first dibs. It goes right to nginx, and then nginx says, hold on a second, does this match up to another container? If so, route it over there, and if not, just drop it, or return some sort of pre-canned error message. So that's what we need to do. The two steps we're going to do right now are installing Docker and configuring nginx to run as a reverse proxy. And luckily, both are fairly simple to do. So inside my SSH session, I'm first going to enter into superuser mode. And to do that, you just type sudo-s. And next, I'm going to run apt-get update. And if you've used Ubuntu before or Debian, you know that apt is the package manager that we use to get and install all sorts of different components onto the operating system. And right after I do that, I'm going to run apt-get install docker.io. And what this should do is completely install Docker for me. Let's just give it one moment. Okay. Now I'm going to run two commands that will make sure that Docker is up and running all the time. The first is systemctl start Docker. The second is systemctl enable Docker. And now I can run Docker -v, and I now see that the Docker command line, the Docker command is returning a version. That's the first good sign. The second thing I can do is a sanity check, and I can run the hello world container. And I see the hello from Docker. That tells us that this machine is now a Docker host, which means we can pull any Docker image from the Docker hub. So in order to pull nginx and deploy it as a reverse proxy, we're going to use a project called nginx-proxy. And I have the command over here in Notepad. I'm just going to go over it line by line with you. This is the first command that we're going to run right here. Oops, right here. Oh, keep accidentally right-clicking. This is the command. And what we're just going to do is run it in a detached mode. The -- detached means that the image should, the command in the container should continue running. We want to give it a friendly name on the second line here of nginx-proxy. And we want to publish port 80 and port 443. The first port in the publish command is the port on the host, and the second port is the port inside the container. So all we're saying is, on the host, let's give this container special privilege to access traffic that arrives on the host at port 80 and port 443. Next, what we're doing is we are publishing a couple of volumes in here. And these volumes, so this basically gives the container access to this path on the host. If you didn't specify this, then the container does not have the ability to access the host's native file system. And that means that anything that it writes is persistent only within the container. And if you shut down the container and restart it, then you lose all that state. And that's exactly why this run command includes these volumes, is so that it can write the state, such as the certs and the host configuration and the routing settings from nginx, into a persistent volume that actually lives on the host. That way, if you ever rerun the container and you map these volumes in, then nginx can restart and pick up where it left off. This final volume is special. This is the Docker socket. This Docker socket file allows us to access the Docker commands from within the container. And notice that we are accessing it in a read-only mode, because this container isn't actually trying to write to the Docker socket. It's not trying to run commands. It's trying to listen for when other containers are being started and stopped. Because ultimately what it's going to do is take a look at an incoming request, take a look at the domain that it's trying to access, specifically the subdomain, and try to map that subdomain to a particular container. And then finally, this is the container image name. So to do that, I'm just going to come in here, paste, and it's just going to pull the image for the first time. And now when we do a Docker PS, we can see that it is indeed up and running. It has this friendly name, and our reverse proxy is now set up. Now the second thing that we want to do is this reverse proxy by itself is already very cool. This means that we can do reverse proxying for regular HTTP traffic. But we mentioned that SSL is extremely important. And in order to add SSL to this is also the reason why we published port 443 over here. We can actually run a container companion container for the nginx proxy right here. And you can see a lot of the settings are the same. So the only thing is that I'm going to come in here and change this email setting right here to my email. And then I'm going to grab this command. And what this is going to do is basically, whenever it sees you starting up a new container and you're specifying the let's encrypt host environment variable, it will go and automatically call certbot, which is the utility that you use to get SSL certificates issued from Let's Encrypt. And I'll provide links in the description so that you can read up on all this stuff if it sounds a little complicated or you just want to refresh it. But now we're going to grab this command and start the Let's Encrypt companion container. Again, Docker PS, and we can see that both containers are happily running side by side. Finally, to make sure that all of this is working, we can run another nginx container, and if we just run nginx by itself, it's going to serve up some default placeholder static files. So we want to come in here and we want to replace this with an actual domain. So I'm going to do test.raccoon.news, and then I have to make sure that below I provide the exact same URL in the environment variable for Let's Encrypt host. The reason why this value is being duplicated is because virtual host is one of the environment variables that the original nginx proxy is looking for. Virtual host is sufficient for the nginx proxy container that we ran up here to route HTTP traffic to this container. But we need the Let's Encrypt host environment variable in order to tell the companion that we actually want an SSL certificate for this subdomain. Now I'll just grab that command. And then now if we run Docker PS, we can see that all three commands are up and running. And now the moment of truth. We should be able to open a browser, point it to test.raccoon.news, and hit that nginx container, and we should see some sort of welcome to nginx HTML page as a placeholder. Let's test it out. There you go. Welcome to nginx, and this is being displayed by the nginx container that we just deployed at the end. And what's really cool is you can note here that we have the padlock icon. This domain is secured by SSL. And in fact, if I click this thing, I can see that the certificate is indeed issued by Let's Encrypt. And I didn't have to do any other manual configuration. I can now deploy any container at any subdomain to raccoon.news and automatically have SSL termination, routing, and SSL certificate management done all automatically for me. I think that's pretty cool.